Good morning to all. Myself Sonia. Today I am presenting my paper on a study of deep learning based segmentation and classification of brain tumor in MRI images. These are the content which I covered in my paper: introduction, neuroimaging modalities, literature survey, conclusions, then references. I will take a brief introduction about the brain tumor. Basically, the brain tumor is an uncontrolled growth of cancerous cells in any part of body, whereas the brain tumor is an uncontrolled growth of cancerous cells in the brain. The brain tumor can be a benign or a malignant. The benign brain tumor has an uniformity in the structures and does not contain the active cells, whereas the malignant brain tumor have no uniformity in structures and contain the active cells. According to the World Health Organizations and American Brain Tumor Association, the most common grading system uses a scale from grade 1 to grade 4 to classify the benign and malignant tumor types. Benign tumor basically can be scanned by the CT or an MRI scanning. The growth is gradually and it doesn't migrate to other organs or encroach on surrounding tissues, and it often has a boundary or edges that may be seen on the CT scan. The benign might be deceiving since they are compressed brain tissues and other structures within the skull, or which can be life-threatening. The malignant brain tumor are often lack distinct boundaries and including the cancer cells. They are regarded as potentially lethal because they spread quickly as faster growing cancer affecting the spine and other part of the brain. Grade 1 and grade 2 are benign stage, whereas the grade 3 and grade 4 are the malignant. And it can be a fatal death if disease cannot be diagnosed in the earlier stage. Next, the neuroimaging modality. Basically, there are three techniques to use to examine the architect of the brain in order to find the brain tumor. First, the PAT or piston emission tomologies. It is a unique class of radioactive tracer is used in a PAT scan. The metabolic characteristics of a brain tumor, including the blood flow, metabolism of glucose, amino acids, are investigated using the PET scan. There are some drawbacks. The radioactive traces used in the PET scans harm the human bodies or cause the allergic reactions. Next, the magnetic resonance imaging MRI. Using the MRI now, it is possible to analyze the many type of brain tumor tissues and research the internal organizations of a brain. The brain tumor the brain tumor in peoples can be using MRI T1 weighted, T2 weighted, or a flare weighted. The images are a few type of MRI that can be used to map the changes map the changes by the tumor, map the changes by the tumor. And basically T1 weighted bright fat make up only the kind of tissues in the T1 weighted. In T2 weighted, bright fat and water both make up the category 2 tissues in T2. The repetition time is slow in T1 weighted, whereas the repetition time and time to echo is lengthy when the T2 weighted is easy. The third one is the flare sequence. It look exactly like a T2 weighted images. The only difference is the time to echo and time to repetitions. Next, the computer tomologies. The computer tomologies provide the more detail than the X-ray. Compared to the ordinary and multiple CT scan expose you to more radiations, which is increase you the risk of the cancer. So, compared to the other modalities, the MRI can detect the tumor at the earlier stage, and it is more preferred. The computer-aided diagnosis systems is the solution used for the brain tumor detection. So basically, there are four stages in the computer-aided brain tumor detection. First is the pre-processing stage, in which the image is made suitable for image further processing, like normalizations, resizings occur in the pre-processing stage. Then after the pre-processing stage, the region will be segmented, and from the segmented regions, the feature will be classified. So this is how the typically flow of the stage of brain tumor. Yeah, so in each stage, more method are being introduced in the so what we use the deep learning segmentation for the future extractions can be done, which can be done automatically, not by hand made, because previously they can be done by the hand made, which was but this are limited in their accuracy. But now this is done by the deep learning model, which is a higher accuracy, and that learn automatically from the images itself. Uh, there are lots of works have been done in the deep learning, and I survey first the Sonia Ben used the deep learning with the EfficientNet BI to detect the brain tumor from MRI images. The MRI they achieved the 98% performance and 97% accuracy on the data set of 3064 brain images. He used the CNN technology for this. Then the Tumala classify of the brain tumor by magnetic resonance image using the set of visions. He used the fixture data set and he used the image net based with technologies and got the 98.7%. Next, the Saif Ahmed used the performance of the deep transfer learning network for the brain tumor detection using the MRI. He used VGG16, VGG19, ResNet 50, inspection R, and V2, inspection V3, exceptions. The results show that the best model has a 10 cross validation accuracy with the accuracy of 99.39. The Shrikant used the multi-class classification of brain tumor images using the data augmentation by deep learning. He used the hospital data set from the which 2010 to 2015 year and used the 16 layered VGG deep neural network that he got a 98% accuracy. Nadeem Mohammed, he used the brain tumor identification using the various deep learning algorithm like YOLO V3 PyTorch, YOLO V4 darknet scaled, YOLO V4 tiny, YOLO V5 and faster RCSN. After the evaluation of the result of these models, he determined that the YOLO V5 provide the best performance as compared to the YOLO V3. YOLO V5 get 95%, and YOLO V3 PyTorch model worst accuracy was the 84.30. Next, Sumit Tripathi worked on the brain tumor segmentations on the MRI images using modified deep learning network. He used the real-time brain tumor MRI dataset, which was fed into the network, deep learning network, and MIOU and BF improved by 7.6 and 7 respectively. The Ahmad Lahav used the work on the brain tumor classifications using the deep learning model. He used the exceptions, ResNet 50, inspections V3, VGG16, and MobileNet. The F1 score invisible images were 98.75, 98.50, 98, 97.50% and 97.25 respectively. So the conclusion is we propose a CNN based approach for the segmenting brain tumor in the MRI investigation. The goal of this research is to reliably identify that the many models used to detect the brain cancers using the MRI data. Basically, brain tumors are the most fatal and life-threatening kind of cancer. So, millions of people worldwide are impacted from this. A variety of brain tumor segmentation and classification approaches have been presented to enhance the medical images analysis. However, there are lots of flaws in this, including the low contrast images, incorrect tumor region segment caused by the certain artifacts, computationally complex method that required more treatment time to correctly identify the tumor region, and existing deep learning method that required a large amount of training data to overcome the overfitting problem. So for this paper, we use the following references. Thank you so much.